Great. So thank you all for joining us today. We're going to be going through a presentation and some of the labs. I have put in the chat the links to the prereqs for the chat. If you can't access the chat, it's in the bottom right hand side of your screen and you should be able to open it up and send messages. I would just make sure that all your messages are sent to all the panelists so that everybody can see the questions and help you out if you have any questions. Otherwise, if you do want to raise your hand, we can unmute you. If you've got questions and things you'd like to ask face to face, then that's no problem. Otherwise, I think we're good to go. So Emily, over to you. Let me pass you over.
Thank you, Helena. Let me share my screen. Okay. Hello, everybody. Thank you for coming to this workshop. This workshop is especially made up for you and to teach you about cloud-native application development. This I am Emily Jiang. I'm the Liberty Cloud Native Architect. I'm also Microprofile Architect. Outside IBM, I'm also Java champion. I'm pretty much working. My full-time job is on the open source project like a Microprofile, Git, Open Liberty, you name it. So I'm pretty much like an open source focused and oriented person. So I'm strongly a strong believer in open source. So with me, Grace, Json, Jimmy, and Grish and Jay. So we are all here to help you with this workshop, and plus we will show you some guides. So I will take you through with the few slides, and then Grace come in to demonstrate like one of the lab, and followed by Jamie will do another lab. So hopefully the one presentation followed by 2 labs. And then at the end of this workshop, hopefully you know where to get started, and you might be able to create your cloud native applications, get it running on Open Liberty without any problem. So that's an aim. This is a roadshow is like happening in like Europe and Asian Pacific, and also we have another one repeating in the Canada and US. So in the other time zone as well. So let's step back to the like early days in the 20th century. So in the back in the like 1998, like it's we still work on the waterfall, and also it's a slow network and etc. In the 1998, Websphere application server was released. And then it's gradually is kind of because we all kind of get the application server installed our desktop with limited resources, and then to ease the deployment kind of the effort that comes with like in early 20th come with the virtual machines. And then it's in order to manage all these virtual machines, and then we came up with kind of clustering technology like Websphere, ND cells, and etc. And then at that time is we are all the resources constrained, and we have like developers and testers, also have the requirements, the planners, and etc. So it's pretty much waterfall. And we build like a monolith. So we release all together and then plan again, and then develop again, and then test again, and then release. So that's kind of the back in the 2000, late like 90s and 2000. And then it's back in the 2012, like as the time goes on, we all feel like this is pretty much constrained, and with the kind of more lightweight like the work type, the work pattern, and then we come from the waterfall and move towards agile because the release cycle is too long. So by the time we deliver a product and then that product is not useful anymore. So we need to shorten this release cycle. So we came up with the new application server, such as like Websphere Liberty. So pretty much like it's very small and very fast. And with time goes on, and basically there's some other companies all come up with a different application server. And then it's as an end user, and you don't need to relearn different things in order to get your application deployed to a different runtime. So that comes with kind of the open standard. So it's like different companies, we come together and say, oh, let's try to come up with a standard, and so that an user can adopt this standard, and our implementation, our product can use this standard, and this is benefit for like an industry and for the kind of consumer. They don't need to relearn similar things over again. They just learn once, use everywhere. So that's come with like all the cloud native APIs such as Jakarta EE and Microprofile, and also gradually we are trying to fix the issue like the problem you often heard, like if like a tester reads a problem and said, but developer will say it runs on my machine, right? So in order to fix that, we came up with the containers. And gradually, in order to manage containers, we come up with Kubernetes. And again, for optimize the Kubernetes, there comes the OpenShift. Nowadays, there's kind of the functions is also popular. So for the very lightweight kind of the compute. So it's gradually is kind of more polyglot and all the different flavors. However, one major thing which is open, the other major thing which is fast. So this is the kind of the trend. So as I mentioned earlier, when the open, so Open Liberty, the name tells you a lot. Is we focus on the open things. We focus on the open standard, open APIs. Like such as Jakarta EE, so we support the Jakarta EE APIs. We also a strong supporter and a driver for Microprofile. And again, also we choose a writer like a JVM and such as Open J9. We work very closely with Open J9 and with this JVM optimization. And with OpenJ9, Open Liberty can start like within 1 second. So it's really like a good open technologies come together to build a great new ecosystem, which is name is open. So in the next few slides, I take you through all these open technologies, all these APIs are available to you if you build like a cloud native applications. So one like a bigger highlight is a Microprofile. So Microprofile was created in 2016. So at that time, Java EE was stagnant. So there's not much movement in Java EE. And then microservice was on the rise. So people started questioning, is Java still valid and relevant for microservice development? When people ask this question, actually tell us one problem, which means Java has not provided you with really like a good cloud native APIs for you to build microservices architecture. So that's why Microprofile was established then. And in the past 5 years, Microprofile progressed very, very fast. And then in this year, like we released Microprofile 4.1. At the moment, I'm driving Microprofile 5.0 release. As a matter of fact, we use OpenLiberty as a compatible implementation to be able to release the Microprofile 5. So this is kind of, I put all these APIs for creating cloud native applications for you to like consider. So the bottom layer, so it's a core layer. So use like a JAX-RS, and CDI, and JSON-B, JSON-P to create your application. And you use REST client to connect this application. And then when you deploy to the cloud, you need to configure it. So you use Microprofile Config. And then is in the integration, you use like if you want to do a lot of queries, and then you might consider to use Microprofile GraphQL. And if you want to create a reactive microservices, and you can choose to use Microprofile React Messaging. And in order to document your microservices, use the Microprofile Open API. And as we all know, when you deploy your microservice in the cloud, you cannot depend on depend on based on the condition, everything else will go smoothly. So you always need to look after yourself. You need to build a resilient microservices yourself. You need to, when you code your application, you need to code it in a way, no matter what happened, my microservice always works. So with that, you will need to use a Microprofile fault tolerance to create, to build a resilient microservices. And also, in order, you need to protect your microservice, you need to secure some endpoint for the sensitive information or prevent from unauthorized access. So you will need to use Microprofile JWT. And this first two layers pretty much give you really robust cloud native applications. However, once you deploy to the cloud, you need to monitor it. You need to think about data operation. So with that, you will need to use Microprofile Health and Matrix, Open Tracing, and lately, because the Open Tracing and Open Sensors merged and came up with Open Telemetry. So at the moment, the Microprofile community is prototyping the Open Telemetry support in Microprofile. So it's, if we have a lot of microservices, and how can we handle the collaboration between them? So if you have hundreds of microservices, you won't be able to remember which one is doing what job. So with that, you will need to use Microprofile Open API to document what microservice is for what purpose. So if you know Swagger is pretty much you know Microprofile Open API already. So Microprofile Open API adopts Swagger and also creates some annotations for you to use, like an API response, and etc., etc. And also in OpenLiberty, we give you a UI, and basically you can access the endpoint, and even be able to evoke the endpoint and see the kind of all the messages in a really graphic interface. Is really nice. And later on, there's also there's a guide in OpenLiberty show you. And the next one is the kind of I mentioned earlier is the secure microservice. So you can use Microprofile JWT technology. Basically, we're passing a token, but this token is being Microprofile-fied. So basically, this token has all the normal token information plus two things. One is UPN, the other one is groups. So is UPN. So basically, it's communicate what is who is the user, and groups is a communicate what groups this user belong to. So with that information, when you use the declutter EE annotations API roles allowed in there, so in this snippet, it means start coffee brew only allow admin or coffee shop access this endpoint. And then in the GWT token, if you pass in this kind of groups, if you say, oh, hi, I belong to admin, yes, you can access this endpoint. If in that token said, okay, I belong to the group super, no, you can't access this endpoint. So very simple. So in the next one is fault tolerance. So basically, the fault tolerance, as I mentioned earlier, provide some APIs for you to create very resilient microservices. So it offers retry and timeout and circuit breaker, bulkhead, and also fallback. So it's for retry. Obviously, if you have any exceptions, it will automatically do the retry. So in this code snippet, actually, if you get a timeout exception, it will do retry. And then you can configure how many times the retry you want to do. And the maximum is 4. So after 4, if you still failed with timeout exception, and this exception will be propagated back to the caller. So it's basically the exhausted of the retries. So the next thing is the Microprofile Config. It offers a way how to configure your microservices. So basically, this one is doing the connection. You can specify your configuration in some config sources, such as inside your application in the microprofile-config.properties, or in the environment variable as an environment variable or as a system property or anywhere. And if you configure maybe in the Zookeeper or maybe in the Kubernetes config map or in console, anywhere. So this is the config property you specified. So obviously you need to make that config property available to your application. Now, how is what Microprofile Config is trying to do? So basically, the offer you can use programmatic API, a config provider. You can directly get a config, or you can directly inject an individual config property. So in this example here, I inject the host into this optional host. So if the host doesn't exist anywhere, the default value will be full.com. So obviously here is specified in the microprofile-config.properties, you will get abc.com into your host. Microprofile config has a great connection with Kubernetes I mentioned earlier. So you can specify your config map, create a config map, and then in the deployment file, and you can map the config map here and as an environment variable. So here the key is the message. So key is the message is mapped to an environment variable name called greeting. So the greetings value will be greetings. And then in your application, basically, I don't know anything about whether config map or something, but I know my application will search all the properties in the environment variable. It will be able to get a greeting. So this variable will be assigned with the value greetings. So you will get this. So next thing is the kind of operation concern. Like when I deployed my microservices in the cloud, I will be wondering, how well my microservice is doing. When I first get it uploaded, I need to make sure it's only is ready and I can receive a request. And then at some time, maybe it's running for a long time, and maybe there's a kind of the RAM issue and etc. And maybe it will die and natural death, and then Kubernetes will be able to recycle this instance, etc. So all this achieved by Microprofile Health. So Microprofile Health offered like 3 annotations. One is readiness, the other one is liveness, the third one is the startup. So basically, this is a very oriented to the Kubernetes prop. So Kubernetes has readiness prop, liveness prop, and startup prop. So basically, it's in Microprofile this annotation readiness, and then you can specify the criteria and when it's ready, when it's not. So here you can implement this interface health in this method is a health check response. So you can see is kind of under what kind of circumstances is not healthy. For example, maybe it's kind of the without a RAM. Obviously, is not this is the kind of the might die, and the other kind of readiness is the most popular logic will be you check the database connection. So in this readiness is healthy, maybe you check the underlying database. If you can reach it, yes, you are ready. If not, no, you are not ready. So in this way, the Kubernetes will not route a request to your application. Similarly, for liveness is, as I mentioned earlier, the logic could be are you running out of RAM? So if yes, probably you will say, okay, liveness is down, and in this way, Kubernetes will recycle this instance. The other thing is the startup. So it's basically it's startup is only startup prop only added to Kubernetes this year in the latest release, and as you know, some the microservices or some modular monoliths will take a long time to start, and if you keep on checking readiness is okay, liveness is okay, or is not live, and activate restart, and you run into the deadlock. So that's why we Kubernetes came up with a startup prop. So basically, it's in startup prop we check whether your application has been started. Yes, with the started, and then it will check readiness or liveness prop. So this is kind of the earlier you can see the logic about readiness and liveness, all this implementation, and how can you connect them with Kubernetes. So basically, in your deployment file, you will see readiness prop and the HTTP GET, and this is path. So the reason is, in the Microprofile Health, it exposes 3 endpoints. One is the /health/ready, the other one is /health/live, the third one is /health/started. So it's readiness prop obviously will be HTTP GET, and the port is 9018 and /health/ready. So you can configure initial delay, second period, how often do you check, and etc. So the next thing is a matrix. So it's as you know, when you your microservice is running and you want to keep on monitoring it. If it's you saw some warning and etc., you might need to take some precaution procedures and etc. So it's with that you will need to add some metrics. So it's Microprofile Matrix added some annotations, and also Microprofile Matrix and collect some metrics and also expose a few endpoints /matrix/application/matrix/base for the base information, vendor information, and application metrics information. So you can add some additional application metrics information using Microprofile Matrix APIs. At the moment, we are in Microprofile community, we are investigating whether we want to adopt a micrometer. So it's in the current stage, Microprofile Matrix adopting job wizard, but it seems like Micrometer is kind of widely used, and then the Specker group, the Microprofile Matrix group, I'm trying to see whether I can directly adopt Micrometer as well. So that's the Microprofile Matrix. So it's in this matrix, actually, is all the matrix data is in the open matrix format. So this is the beauty of the Microprofile Matrix, and because it's kind of a natural fit into Prometheus and also Grafana, so you can see them like a graph. You can see the graph straight away. If there's some like a trend or like some warning signal, you can take some actions based on this matrix data. So next thing is kind of the diagnostic issue, and we are in the microservice world, and you have many microservices. If things goes right, yeah, that's everyone living in a very happy mood. However, if something goes wrong, we need to figure out which microservice is not behaving. And if your operation go over to many microservices, and it's very difficult to manually work out. So with that, so it's we need to have a graph. Like we need to see this request and visited so many microservices, how long it is spent in each microservice. If something goes wrong, we need to figure out which one is to blame, which one to be fixed. So with that, Microprofile Open Tracing automatically correlate all these spans. So you see the one operation, and then using the Jaeger or the Zipkin, this tracer implementation library, you can see the kind of all the flow, and you can work out the which one is having a problem, and you can fix it. If you want to add some additional tracing, you can use the Microprofile Open Tracing API and trace to add some like an actual trace. But by default, all the JAX-S method automatically traced. So that's why it's kind of your microservice. You should use JAX-S to create a microservice, and then you can rest assured all the rest of things will be happening, like a tracing. And then you can use all the other like Microprofile APIs, and they will all all the open API is automatically work for the JAX-S endpoint. So this is a quick run through of the Microprofile. So to in summary, it's open standard, and it is governed by the Microprofile Working Group and the Eclipse Foundation. It has a wide vendor support. It's about 12 implementations of Microprofile releases, and it has the open API, JWT, fault tolerance config, and etc. If you want to get involved, check out in the microprofile.io and to see what's going on. There's guides, there's blogs, and there's news. And also, if you want to join, and tell you how to join, if you click on the right hand side, if you click have the conversation, you will see the Google group mailing list, etc. And this is overall the release, and also this is Twitter. And if you ask Stack Overflow questions, would be would be a lot for Microprofile as well. So next, let's have a look at the Open Liberty. Open Liberty is the implementation for Microprofile. Is one of the implementation for Microprofile, and Open Liberty also one of the implementation for the Jakarta EE. So one thing I want to highlight. Open Liberty is a strong supporter for Microprofile, and for Jakarta. So it's a kind of open standard focused runtime. Open Liberty on top of the APIs, because we promote open standard APIs. Also, we focus on the usability. So it's Liberty is developer friendly, and also give you just enough runtime for you to run your application. For example, if you don't use EJB, and it won't load any like a runtime support EJB. And there's a Liberty dev mode. If you're not tried out, and please go and have a try. So if you do a Liberty colon dev, and you can start up your application and code along, you can see the changes straight away. And the other highlight is Liberty which is different from other like lightweight application server is zero migration. So once you write your application and you stay, assured your application will always work in the new Liberty releases and etc. It's because of zero migration. In the Liberty runtime, we have all the previous features. When we always add things, we don't remove things, because we want to reinforce zero migration. So if you have done your application, you can move up to use the latest Open Liberty, and you can make better use of the new kernel and new technology, but your application will continue to work. And also it's cloud ready. And we invest a lot in our Docker, as a support. We have Open Liberty operator, and we always strive for the small memory footprint and fast startup. The other beauty is we have a self-tuning thread pool. So it's automatically, you don't need to think about, oh, how many thread pool do I need, how many thread in each thread pool. Look, Open Liberty use really optimize the algorithm to work out how many threads in the thread pool and etc. So this is the kind of I mentioned just in time enough runtime. For example, in your server XML, you say, oh, hi, I only want to use JAX S21, and then the runtime is only load enough with the bundles to be able to support JAX-S. So it has a kernel and also has the feature, support JAX-S. There's nothing else. You can see there's no EJB, no CDI whatsoever. It's just enough thing runtime for you. So the recap, Liberty is a strong supporter for the open standard support for the from very beginning, from the Java EE, web profile in 2014 and Java EE 7 2016. And also we want to, once there's a new release, we want to get there first. So we have Java EE 8 2018, EE 9 2019, and also Microprofile. We're trying to first to deliver all this Microprofile release. As I mentioned earlier, at the moment, in the Microprofile folder 1 and 5.0, we use Open Liberty to be able to get a Microprofile release auto door. So you can see Open Liberty is so focused on the open standard and trying to contribute towards the movement in the open standard communities. And in the Jakarta EE9, we are also the first vendor to support, and we are working towards our beta is already Jakarta EE9 kernel certified, and we are trying to GA Jakarta EE 9.1 very soon. So this is to give you another picture of the Jakarta EE APIs and Java EE 8 APIs. So it's so this is all the Liberty features corresponding to the Java EE or Jakarta EE technologies, like a batch, like JAX-S, CDI, JSON, JPA, and etc. etc. So this is another we mentioned earlier. All this mentioned here, all these that we have support all these APIs from Microprofile. And if you are a Spring Boot user, and you can continue deploy your Spring Boot application to Liberty, like a Spring application to Liberty instead of to Tomcat, you still get a benefit about all the kind of the Docker support and etc. etc. So recap, like we continue invest time and effort towards developer joy. So we want to make sure our developers can like stay focused with their business technology and all the rest, all the tooling and etc. We provide all the amazing experience. So basically, as I mentioned earlier, like once you start your cloud native application using, if you are Maven user, you use the Maven Liberty Dev or Maven Liberty Dev C. If a Gradle, you use the Gradle Liberty Dev, and then you can start a code of your application. You can like the behind the scene, all these plugin automatically rebuild and reload hot deployment and running the test. And before you know it, and you don't feel like you have a server to look after. Basically, the runtime look after you instead. So with the like all the tooling, and also we have the Liberty Starter. So it's as I mentioned earlier, all these we are very open standard focus. When you create like the cloud native application, very often you will need to use the Jakarta EE or Microprofile. So you can come here to create either Maven or Gradle project, and then we generate all the kind of the necessary files for you, and then you can start writing your business logic. So this is the quick end-to-end developer experience. We have like I mentioned earlier the dev mode and also the starter. And also we are like invest a lot to help out Microprofile Starter. We invest time to do the like a VS Code plugin. So it's if you are using IDE in the VS Code, you can directly install the Microprofile extension pack. That also has the liberties like some tools to help you, plus other runtime like tooling available to you, and also we have some plugin for the IntelliJ if that was your favorite IDE, and we have like pushed our Liberty over these features to Maven Central, and also we have the Docker image, the base name image available in the Docker Hub, and then we support both the Maven or Gradle as a build. And as the API, as you can see, you can use Microprofile, Java EE, Jakarta EE, or even Spring Boot. And for testing, we also have microshed testing, so you can do a container testing. We also support like a promote JUnit, Aquilian, and etc. So the next, this slide is what people are saying about Open Liberty. So it's to call out a couple of things. It's remarks. Liberty is faster to configure application server with some advantage over other similar products. So if you have not tried Liberty, go and try it out yourself. So here, now that we have experienced Liberty, we are spoiled. I want to stick to those easy, no impacting migration. So this is easy to use, and also rest assured you have a zero migration protection. So what's next? So it's so this is pretty much toward the end of presentation. So it's if you have not logged on to the openliberty.io, go to openliberty.io. You can see a lot of guides. So this is a lot of the Microprofile guides. If you search, if you go to guides, or you can click here guides, and then you can search microprofile and then list all the microprofile guides. On the left, you can just choose which area you want to focus on, you get a guide. So most guides is kind of within 30 minutes, 15 to 30 minutes. So each day, if you want to learn something, just go and try out one of the guides. So Open Liberty is open source. You can see everything about what we are doing, and you can even see the kind of the roadmap here. You go to Open Liberty roadmap, and you can also request a feature. And then if you feel you have some good ideas, and maybe Open Liberty is lacking, you can raise the issue, and then we will evaluate it. And also we ask for contributions. If you have free time and etc., you can read our contribution guide and then start to contribute. So this is all the useful links for the Open Liberty. If you have not followed Open Liberty Twitter, we tweet all the new guides. When we keep on developing the new guides and refurbish the existing guide, follow Open Liberty IO, and you will get up-to-date information from Open Liberty. And the next thing is this year, I co-authored a book, Microprofile in Practice. So basically tell you everything about microprofile, all the specifications with a real world application. So IBM Stock Trader. So it's, if you would like to get a copy, please go to Amazon. So this is a short URL take you to the Amazon. This is a QA code I created, and please take a photo and you can directly navigate to Amazon. So there are some reviews, and you can read the reviews to learn what other people say about this book. So now next is hands-on for the kind of the Java for this workshop, Java workshop. And with that, I will pass on to Grace to first go through the first guide.
Perfect. Thanks so much. So we're not going to use the link that was in Emily's presentation for this one. We're going to be using the local guides. So that's why the prerequisites were in the chat earlier. So hopefully, if you haven't already had a look at those, please take a look and see if you have those pre-downloaded onto your local machine, because we're going to be doing this locally. So if you don't, then they're at the top of the chat. You should still be able to find them. Please let us know if you can't, or if you have any difficulties. Oh, they've been reposted. Thank you, Helena. So they have been reposted in the chat, so you should be able to see all of those and access them. I'm going to be going through the guide with you at the same time, so you can follow along with me, you can just watch, or you can do it yourself at the same time. Totally your choice as to which you'd rather do. I'll keep the chat open just so I can see anyone making comments, etc., in case you have any difficulties with this. I've put the link directly to the guide we're doing. So as Emily pointed out in her slides, this is on the Open Liberty website, so openliberty.io. It's one of the guides, so it's in the guides section, and this one is all about adding health reports to microservices. Now, Emily covered this a bit within her presentation about, it's very important when we have these microservices that are all distributed to know that they're up and healthy and working as they should do, so that our application as a whole is working as it should do. And we can use Microprofile for this when we're checking the health of these distributed microservices. So that's what we're going to be doing in this first lab, is just checking out how do we use things like the liveness and the readiness aspects of Microprofile health to be able to check the health of our microservices. So if you're already on the openliberty.io guides page, if you just want to search for health, two guides will show up, one with Kubernetes, one without. We're doing the one without Kubernetes first. Otherwise, you can just head straight to the URL I put in the chat. So as I mentioned, we're going to be checking the health status of microservices. Now, the great thing about our guides is that actually we try and utilize the same application throughout each of our guides. So that makes it really easy for you to focus on the technology you're trying to learn instead of trying to understand how the application works as well. So this application is normally made up of two different microservices, a system microservice and an inventory microservice. The system microservice essentially polls your machine to find out your system information every 15 seconds. And the inventory microservice stores the most up-to-date information that the system microservice has got. So it polls that system microservice for that information and stores it. So we want to be able to check whether these two microservices are up and healthy. And to do that, we're going to be using Microprofile Health. If a service reports that it's up, it means it's available. If it reports that it's down, it means it's unavailable. So it's a fairly easy up or down message that you'll get back to show you whether it's available or not. So as I said, we're going to be using liveness and readiness checks for our system and inventory services. And we've already provided you with the system and inventory microservices, so we've made that as easy as possible. We're just going to be implementing the actual adding of those liveness and readiness checks as part of Microprofile Health. So the fastest way for us to get started is to utilize the Git repository we've already created. Again, as Emily mentioned, this is all open source. So if you want to go ahead and check out that Git repository in more detail in your own time, we'd welcome you to. Or in fact, if you want to add anything to it or suggest changes, then feel free to open some issues. So to do that, we're just going to use a Git clone and make sure you're CDing into the correct directory as part of that. I've already done that in my terminal. So you can see I've already cloned the repo. And actually, if I go back a directory, you can see what's inside it. So once you do your Git clone, you'll see a sort of similar structure to the one that I'm showing here. So you'll see that you've got a finish directory and a start directory. Now we have this in all of our guides. So the finished directory is what you should get to at the end of each guide. So it's the finished product of what you should be achieving once you follow all the instructions. And that can be really useful if you want to try out the guide before you actually go through the steps, or if you have issues, for example, maybe you've copied and pasted some of the code wrong, maybe you've edited some and it's not compiling, for example, or something's gone wrong, you can then check it against the finished directory and see where the differences are for bug fixes. So it's quite useful for that as well. The one we're going to jump straight into is the start directory. Now, in the instructions, you'll see that we do show you sort of what you can do to try out the finished directory first. But just in the interest of time, I'm going to jump straight into the start directory, which is slightly further down, all the way down here. So if you would like to go away and try out that finished directory first, absolutely feel free. We're just going to jump straight into actually adding in our different checks. So I'm going to CD into the start directory because that's where I need to be able to make all of these changes. And in here, you can start to see this file structure that you'll see in my IDE here. So you can see within the Java IO OpenLiberty guides directory, you can see our two microservices, so inventory and system. So the first step is that we're going to be running this in dev mode. So like Emily mentioned in her presentation, we have this dev mode, or it's short for development mode, and it means that essentially our server is listening for file changes and then is able to automatically recompile and deploy whenever we save a new change to a particular class, for example. So to get that running, we're going to be using Maven, and we just use the following command. So Maven liberty:dev, and we can just put that into our terminal to get that started. Now, as you saw, there's a very helpful copy button in our instructions here. So it means that if there's a long piece of code, for example, or a long piece of instruction, you can easily copy that in. So you can just paste that into your terminal, hit enter, and it will automatically start building your application utilizing Liberty Dev mode. And so that's going to be really useful for us as we go through this guide, because it means every time we do a small code change and save it, it will automatically recompile, and we don't have to do that from scratch every time. So it really saves the time when we're developing, which is quite helpful. So you'll know that the application is ready in this dev mode when you see the following message. So you'll see a lot of stars, and then you'll see the message Liberty is running in dev mode. And that's how you know that you're ready to begin making those edits and that your server is up and ready to go. So dev mode holds your command line session. And as I said, it listens for file changes. So if you want to do anything in addition using your terminal, then you'll want to open a new terminal or a new tab in your terminal because that terminal you just used is going to be running in dev mode the whole time. So you won't really be able to do any additional commands. You'll need another terminal for that. So let's go back. Yeah. So you can see here, we've got those stars and that message, Liberty is running in dev mode. So we now know that it's ready to go. So the first thing we're going to be doing is adding the health check to our system service. That was one of our microservices. So to do that, we need to create this system readiness check class. So I'm just going to copy the name across just to make it easier. Head on over to my IDE, head into the system inventory, system directory, and then add a new file. So we're adding the system readiness check.java class. And then we've already provided the code here on the right-hand side for you to utilize. So all you need to do is just make sure you're in the right one here. Sometimes if you scroll down a little bit further, it will pop to the next class that you need. So just make sure you're in the correct class. It will be grayed out slightly to show you which class you're actually looking at. So then you can just copy and paste this code across, select all, paste, and do remember to save. And actually, when we save, what you'll see is that we've just recompiled because we just made a change. And remember, we're in dev mode, so we're automatically listening out for those changes. So what we've done here is, what you can see is we've actually added the @readiness annotation. So that was one of the annotations shown in Emily's slides. And this indicates that a particular bean is a readiness health check procedure. So by pairing this annotation with the application scoped, it means that we have the context from CDI API, which is another microprofile API. It was in that stack that Emily showed. And it means that the bean is discovered automatically whenever the particular endpoint, so in this case, we're using localhost 9080/health, receives a request. So I've already got a lot of the sort of URLs that we'll need later open. We will be shown them as we go through the guide. However, if you did the finished one, you'll see a lot of them listed here as well. But as I said, we'll be going through them in this guide anyway. Let's go back down. So we're also utilizing, oh, we've switched that one, switch back. So we're also utilizing this call method. In this call method, we're using it to return the health status of a particular service. So in this case, we're just checking whether the server name is default server and returning up if that is correct. Otherwise, we're returning down. This is a very simple implementation of the call method. In a real environment, you probably want to orchestrate something more meaningful within your health checks. But at the moment, we're using a very simple application, and this is just to show you these annotations and how you might use them. So now that we've created that readiness check, we're going to create a liveness check for the same microservice. So for this, you want to be creating a system liveness check class. So again, I'm just going to copy across the name just to make it easier. Head on back to your IDE, add a new file, name it the same, so system liveness check.java. And then we're going to head back and copy and paste the code we provided here on the right-hand side. So again, select all, paste, and save. So in this one, instead of using the @readiness annotation that we saw here, we've now got the @liveness annotation instead. So this is basically checking heap memory usage. So we're checking that if we've got more than 90% of the maximum memory being used, we're going to put a status of down to be returned within this liveness check. So that's the system microservice done. What about the inventory microservice? We need to do similar steps. So we're going to create a readiness check and a liveness check. So again, we're going to copy and paste in the name of this. We're going to do the readiness check first. So this time when you're in your IDE, don't head into system, instead head into inventory. And again, create a new class. I'm just copying and pasting over the titles to make it a bit easier. So this is going to be called inventory readiness check.java. Just hit enter to create that. And make sure again that you're on the correct file up here. So you should see it grayed out, inventory readiness check Java. So then you can copy and paste in all of this code, copy, select all, and paste and save. And you can see again, we're utilizing that @readiness annotation. So in here, what we're utilizing is this isHealthy method. And this method essentially helps us to report the inventory service as not ready if the service is in maintenance or if its dependent service is unavailable. So for simplicity, what we've done is we've essentially created a config file. In this case, in fact, I'll show you in the IDE. It's underneath, so where you say start, it's underneath resources, and we created this custom config source.json. So in here, I'll head back so you can see it. In here, essentially, we've created this IO Open Liberty Guides inventory in maintenance. And essentially we can use this to indicate, to basically simulate the service being in maintenance. This file's already been created for you. You don't need to edit it at all. I'm just showing you what it looks like. So this is essentially what we can utilize to trigger as if that microservice was going into maintenance and see whether our tests pass or fail, and ensure that we're able to see if we've simulated it being in maintenance, do we see those health checks coming down as down or as up? So checking that they're working correctly. So going back to the inventory readiness check, what you'll also see is that we're utilizing a GET request, and essentially this is to check, it's a GET request to the system service, and it basically checks its status. So if the request is successful, the inventory service is therefore healthy and ready because its dependent service is available. Otherwise, the inventory service isn't ready and an unhealthy readiness status is returned. If you're really curious about the injected inventory config object that we're utilizing, or you want to learn more about Microprofile Config, which Emily went through a bit in the presentation, then we do have a separate guide on that, and you can check that out using the link here in this guide, or going back to the general guides page and searching for config. So now that we created the readiness, we're going to create the liveness check. So again, we need to create a new class for this. So head back to the IDE and then make sure you're in the correct repository, and then add a new file, paste the name, enter, and then we're going to copy and paste this code. Copy and paste this code here. So again, similarly to before, this time instead of a readiness, we've got an @liveness annotation. And again, we're just checking the memory heap response, so whether it's over 90% or not. If it's over 90, it's down. If it's below 90, it's up. So now that we've got all of those checks set up, we're going to try and run our application. Now, because we started this in OpenLiberty in dev mode, what you'll see is that our application has been successfully recompiling as we've been saving all of those changes and making all of those updates. So actually what we can do is just navigate to the health URL to find out whether the liveness and health reports on the two services, what they're like. Are they up? Are they down? Now I've already got it open, but feel free to just click on that URL or open it in a new tab and you should be able to see it. So it'll take you to something like this, and if I refresh, there we go. So all of my systems are up, and you can see that we've successfully been able to create those liveness and readiness checks. You can also check out the individual URLs to view the readiness and the liveness separately. So if you do want to view them separately, you can head on over to the separate URLs, which you can see here and here. So you can see they both show similar information. It's just this URL shows them all together. So heading back to this guide. So what we're going to try is we're going to try and simulate that service essentially being put into maintenance. So to do that, we're going to head back to our IDE. We're going to head into resources and into the custom config source.json, and we're going to change this value from false to true. Make sure you save, and you'll see that again, we've automatically recompiled. So now that we've put that into maintenance, what we should see is that actually we should see that the state of the inventory service has changed from up to down. So if we go back to our health endpoint, refresh, and you can see it's now changed to down for the inventory service. So because the inventory service is down, overall, as you can see here, the overall state of the application also changed to down as a result. Make sure that when you're done checking this out, that you put it back to false, because we're going to go on and create some tests. So we want it to be back out of maintenance before we do that. So testing health checks. So we want to make sure that these health checks are working effectively without us going in and manually changing all of this. So to do that, we're going to create a testing series of tests essentially. So we're going to create this health it.java class. So this time we're going into the test directory. So when you're in your IDE, I'm going to close that resources for just now and close main. You can see that there's a different option, which is test. So head into there, and then you want to head into health, and then we're creating a new file, paste the name. So it should be health, then capital it.java. Click enter to create that class. And again, you can just copy and paste all of the code we provided for you here. Now we've got quite a few tests in this, which we do explain within the instructions on the left-hand side. So if I paste that in and save it, if I head back, I'll show you what they each mean. So we've got a test if services are up test, which essentially compares the generated health report with the actual status of the services. So do they match? We've got the test readiness test case, which compares the generated health report for the readiness checks with the actual status of the services. Test liveness is really similar, but this is for the liveness checks versus the actual status. And then we've also got a test if inventory service is down. And this puts the inventory service in maintenance by setting that in maintenance property to true. So it does that for us, just like we were doing manually before. And then it compares the generated health report with, again, the actual status of the services. We've included a few more tests just to verify the basic functionality of both services, and they can be found in our endpoint.it.java class and our system endpoint.java class as well. So if a test failure occurs, then you might have introduced a bug into the code. When we first run these tests, you shouldn't see any failures. We're going to introduce some later on, but for just now, we're just going to run the tests and you should pass them all. If you don't, you might want to have a look at the finish directory and see where you have differences. So because we started OpenNivity in dev mode, we can quite easily run the test by just clicking enter. So if we go back to our terminal, again, you can see we've been recompiling as we go along. So now if I hit enter in my terminal, it automatically runs the tests that I've created. And it's fairly quick because, again, we're not having to recompile this all from scratch. So you can see that we were able to successfully run all of the tests that we created and those additional tests that I mentioned in those additional classes. Now, you might notice that there are some error messages that are coming up. Now, they are expected. So, for example, the first warning message results from a request to a service that's under maintenance. So this request is made in the test if inventory service is down test from that endpoint IT integration test. So we were expecting that. The second warning and error messages results from a request to a bad or an unknown hostname. And this request is made again in another test. So in the test unknown host test, again from that other integration test suite that we had already put into this application. So to see whether the test actually detects a failure, we can manually change that configuration value again. So we're going to go back into our IDE, head back into resources and back to that custom config source.json file. And we're going to change this value from false again back to true. So this essentially allows us to detect whether our tests are successfully detecting a failure or not. This test failure, we should basically rerun the test and see a test failure occur because now the initial status of the inventory service is down instead of up as we were expecting. So again, we just saved it. So again, we've been able to automatically recompile. So I can just hit enter again and it will rerun my tests with those changes. So what we should see, yeah, fantastic. So we should see that we have failed because we no longer match that initial inventory status. It's no longer up, it's down when it initially starts. So we're failing those tests. So fantastic. We've been able to show that our tests are successfully working and we've been able to introduce liveness and readiness checks for each of our application microservices to test the health of them. And that's the end of the guide. So if you want to get out of dev mode in the terminal you're running, you can just use, if you're on a Mac, for example, Control-C, or you can open a new terminal, or you can press Q, sorry, is another alternative. So fantastic, so we're out of dev mode, and that's how easy it can be to add health checks into your microservices using Microprofile Health. So I'm going to pass over now to Jamie, who's going to show you how you can enable that utilizing Kubernetes.
Let me just share
Before
my screen.
Jamie started, are there any questions? Well, Jamie is getting ready. Are there any questions for Mia and Grace? Please post your question on the chat or just unmute yourself to talk.
That is a good point. I am going to put in a chat to in the chat a link to the guide I'm about to do. Okay, so if there's no questions, I will get started. So good morning, good afternoon, wherever you are. So today I'm going to be building upon essentially what Grace has done and actually deploying this to a Kubernetes cluster and showing you a little bit how it works. So this is the guide we're going to be doing today. The prerequisites are you need Java, you need Git, you need Maven. You will also need Docker and Kubernetes. So if you've got Docker Desktop, it does come with Kubernetes. I'll just quickly show you how to enable that. So if you open Docker Desktop, it'll bring you here. If you go to settings, there's a Kubernetes setting, and you can just click enable Kubernetes. It'll take a couple of minutes to set up your cluster, etc. But it is required to do this one. So I'm going to move that over here. So let's get started. So basically, we're going to be building upon what Grace has done, and we're going to actually be deploying this. So first things first, we need to download the Git repo, and then navigate into it. Like Grace mentioned, there are 2 directories in here. So we're going to be working from the start directory, and from there, I'm going to open my IDE. Okay, so first of all, we need a terminal, which I've already got. And what we need to do is make sure we can actually talk to our cluster. So kubectl get nodes is a good way to do that. If it returns something like information about our nodes, we know we can access our cluster. So the cluster name is called Docker Desktop, and because this is provided by the Docker Desktop application. Okay, so we're in the start directory, great, and we have our system and inventory applications, just like Grace was using. So first, what we're going to do is we are going to create a readiness check in the inventory application. So if we open inventory, go source, main, Java, inventory, and then in here, we want to right click new file, and this new file, bear with me. Let's try that again. Okay, there we go. And this one we're going to call inventory readiness check. Readiness check.java, of course. Cool. Okay. So we've got our new file here, inventory readiness check, and essentially I'm going to copy the code in. So the code is coming again from the guide I'm running through. So you can copy it just up here, and then I'll quickly walk you through what this code is doing. Okay, so essentially, we have basically annotated this with the @readiness annotation. This essentially says that we're going to be using this class for our health check. And basically, the inventory microservice should be healthy only when, obviously, system is available, because they're microservices and they're working together. So to add this check to the /health/ready endpoint, we need to create a class that is annotated with the readiness class, so like this one here. So the health check essentially verifies that the system microservice is available. The system service host name is only accessible from inside the cluster, so we can't access that ourselves. It is available, and then it will return basically an up status if it is. Similarly, if it's unavailable, it will then return a down status. When the status is down, the microservice is essentially considered unhealthy. So we've got this. So yeah, basically we're just saying that this is what we're going to use, and we're going to go and check that to make sure the system microservice is in a good state before obviously we start serving requests to make this microservice in a good state. So next we're going to essentially create a liveness check. So in the same directory as before. So we're going to call it inventory liveness check.java. Cool. And I'm going to again copy in some code. Quickly walk you through it. So again, we've annotated here with the @liveness. This kind of checks that the heap memory usage is below 90% of the maximum memory. If more than 90% of the maximum memory is used, a status of down will be returned. So the health checks for the system microservice were already implemented here, which we did in the previous one. So the system microservice was set to become unhealthy for 60 seconds when a specific endpoint is called. So this endpoint has provided for you to observe the results. So essentially what we're going to do is we're going to hit an endpoint, and we're basically going to make one of our microservices unhealthy so we can kind of see what goes on. So next we need a Kubernetes.yaml. So do that from the root directory up here. .yaml. Cool. And basically this is what we're going to use to deploy our microservices to Kubernetes. So again, I'm going to copy in the code. The main things you need to know in here are obviously the readiness probe and the liveness probe. We set the path. So this is the path the probe is going to check to make sure it's healthy. We've got the port number set there. The initial delay, so it'll wait 30 seconds before it starts doing this, because generally you've got to wait for your application to come up. It's got a period of timeout seconds, so basically how long it'll wait before it times out, and it's got a failure threshold of 1. So essentially allow it to fail once before not trying and basically saying your microservices are healthy. Very similar with the liveliness probe again. So we've got the endpoint here. Again, we've got initial delay of 60 seconds, timeout of 3 seconds, and the failure threshold 1. And it's pretty much exactly the same for the inventory microservice as well. Okay, so now we've got that. Just make sure you've saved it. Now we're going to go and build our application. So if we go back to our terminal, now we need to do a Maven package. So what this will do is essentially compile our code, build it all, and put it into WAR files. And what we're going to do is essentially put them into Docker images. We're going to, by building them, and then we're going to use those Docker images and deploy to our local Kubernetes cluster. Okay. So we've built our application nice and quick. I'm going to pull down the latest OpenLiberty image just to make sure I've got the latest version. I'm pretty sure I do, because I did a demo this week, at the end of last week, but we'll try it anyway. So give that a moment. And then once we've got the latest image, now we want to go and build our different microservices. So docker build-t system 1.0. I should have snapshot. I believe that's what it's called. Yep. System /dot. So this basically, the last part where it says system / and the dot, is basically saying to use the Docker file that's provided inside the system directory. So I'll just run that. So again, nice and quick. All it's got to do is throw in the WAR file. So as you can see here, it's running a script, run config. It's called configure.sh. The reason for this script is, you don't have to do this. This is, if you look in the Docker file, you can see it's there. In regards to the label, this is just what you should do with Docker images, but this isn't required. You can remove that. And essentially what the script is doing is it's updating all the packages inside of the container, because we don't want to do that when we deploy our application server. But while we're building it, it makes sense to try and update all the packages to avoid any vulnerabilities going forward. It usually takes about 30-40 seconds, so hopefully it should be done in a moment. And then we're going to go and do the same. We're going to go and build the inventory microservice. Again, it's going to take our WAR file that we just built with our Maven package command. It's going to put that into our image, and then it's going to run the configure.sh again, just to make sure all our stuff is at the latest level. So just give this a moment. I should, for demo purposes, probably remove the use of that script. So what did I just build? I just built the system one. Let's just comment this out on the inventory one, just to make sure things are a bit quicker. I think it should work without that, but we'll find out in a minute. All right, so now let's go and build the inventory one. Oh, helps if I spell it right. Okay. So again, it's going to go build our application. It's going to go build it using the Docker file in the inventory thing. So that's all done. We've got our images built. So if I do Docker images, we should see both of our newly created images at the top. I do have a lot, so I do apologize. Yep, created 52 seconds ago and 11 seconds. Awesome. So now we need to go and essentially deploy our application server. So make sure we have our Kubernetes YAML, which is not in this directory, funny enough. I'm not sure where I put that. So I put it in inventory. So I should be able to hopefully just move it up there. Not. We can do this an easier way. Get into my package explorer. Websphere user group guide. I've got it in start. I put it in inventory by mistake. So let's move that to the parent directory. Okay, so now it's in the right place. Awesome. Let me just double check again. Yeah, there it is. So to deploy your applications, just do kubectl apply I'm going to use -F just to make sure everything gets deployed properly. And then just specify your YAML file. Okay, so this will then now go and deploy these things. It's saying unchanged, so I've got a feeling I may still have this running from yesterday. So if we do kubectl get pods up, so all my stuff's all running from yesterday. So let's just hope this all works. I'm not going to redeploy it. I'm just going to carry on. Worst case scenario, all you have to do is run kubectl delete -F rather than apply. All right, so what we're going to do now is we're going to hit an endpoint. So the endpoint is essentially going to take one of our microservices down and make it unhealthy. The host name here for me will be localhost, I presume, because I'm using a local Kubernetes cluster. So let's hit that endpoint and so it says it's now unhealthy. So if we go kubectl get pods again, we should notice one of them go unhealthy when the probe hits it. There you go. So as you can see, it's gone unhealthy. The checks have basically failed and it's taken that down. Now, as a result, what we should notice is if we hit that twice, so if I hit, let's hit the curl command again, we can take our other microservice down. So it'll now take the second one down. And then we should notice that the inventory microservice also is now not ready, because basically it can't communicate with the system microservice. It's trying to do that health check and now it's failed. Now, it will only last about 60 seconds. It will come back up afterwards. And what we should observe is once the system microservices come back up, the inventory microservice will then do its checks again and then move it back into a ready state, but only once it can communicate with the system microservices. Again, I think it should go down for about 60 seconds, so I'll leave that for a moment. So that's pretty much how you kind of go about implementing this in Kubernetes. So now we can see the system microservices came back up. The inventory service can now talk to that system microservice again, and now it's changed its state back into ready. And the great thing about this is, I mean, when you're in a cloud native world and you're deploying lots of microservices, not only do you need to make sure that say one microservice is in a good state, but you also need to make sure that it can communicate with other microservices and they're also in a good state. There's no point, say, the inventory microservice sending off loads of requests to a microservice which is not ready to receive those requests. And as you can see now, everything's kind of come back online and it's all working. So that's pretty much it. I'm just going to quickly show you how we can test against this. Very simple again. I'm using the Maven failsafe plugin. I'm using these environment variables, so -d basically sets another variable. And then we've got the system service route, which again should be localhost. And same for the inventory service route. Okay, so give that a second. Again, it's just going to run our tests against our local cluster. If you were running on the cloud, again, you would just change the local host to whatever the IP address is of your cluster. So 2 tests have passed. That's a good start. Let me just make sure the inventory tests pass, and then we should be all good. Awesome. And please do something which I didn't do last night, is to delete your deployment. It's not too bad because it's running locally, and obviously while my computer is shut down, it's not using any energy. But if you're using a cloud, etc., it's going to cost you money. So just do make sure you clean up after yourself. So by doing that, kubectl delete -F, just put kubernetes.yaml, and this will basically then go and delete all our deployments, etc. So that's pretty much it for what I had. And yeah, just kind of demonstrate how you can use these kind of cloud native technologies such as Microprofile to create robust microservices rather than, I've got a microservice, I've built something. We do need to build robust microservices. Otherwise, we're going to have a lot of problems later on down the line when we're trying to manage these deployments in production. So without further ado, I will hand it back to Emily to close up. And yes, if you've got any questions about this, please do let me know.
Thank you, Jimmy.
No worries.
Thank you, Grace, for the great demonstration of these 2 labs. Let me ask attendees, are there any questions for us? just feel free to unmute yourself or raise a hand or post a question on the chat.
So, like Emily, like you mentioned earlier, there is loads and loads of different guides. We just went through 2 of 57, maybe 60, and they cover loads of different technologies. There's loads around microprofile, Jakarta, containers, different clouds. So do check it out. Yeah, people do really like our documentation. So we've kind of tried to create an open source friendly documentation that's easy to consume for developers. So do check it out because there is loads and loads of different content on there. And again, I think Grace mentioned this, if we're an open source project, so we do welcome contributions. If you try one of our guides and you think there's something missing or there's something else you wanted to learn, just let us know, and then we can kind of try and prioritize that. And again, feel free to contribute if you want.
Yeah, absolutely. And also, if you want to discuss any like features you have in mind, also speak up, and also we can have a round the table conversation as well. Let me give a 1 minute for you to think about it. If not, actually, I would like to show you one more thing, which is the demo mode. It's kind of the starter. So it's as Grace and Jamie showed you about the guide. So when you have the guide, basically you already have the cloud native applications available to you. You might be thinking, okay, how can I start from 0? So, and I want to take you through a very smooth experience. How can you start with nothing? And then you can build your cloud native applications. So this is pretty much like the kind of from 0 to hero journey. So let me pause here to see whether you have any questions. Okay, let me share my screen. So you can see my screen here. Like if you want to start from scratch and to create applications, like in OpenLiberty, we have start.openliberty.io. So you can see it's group ID, artifact ID, I can see Roadshow, and then you can use whether you use Maven or Gradle. So it's yeah, you can choose either Maven or Gradle, and then as you can see, actually, you can even use Java 17. So it's if you are on Java 8, you choose 8, 11, or 17. So this is 17 is the latest Java SE version. So this is what I said earlier. OpenLiberty is really on the bleeding edge of the supporter for cloud native open source initiatives. So basically for Java, for OpenG9, for Jakarta EE, for Microprofile. So it's here you can see the Jakarta EE 8, and here the latest release version, which is Microprofile 4.1. You can't use Microprofile 4.1 works with Jakarta EE 8. If you want to use Jakarta EE 9, you have to use Microprofile 5.0, which is still in the works. So it's basically that we were trying to put in the Liberty beta and trying to release the specification at this moment of time. So here you can choose Jakarta EE 8 and Microprofile 4.1, and then you can generate a project. And then you can generate a project. You can see here, so open, and you can see what's in it. So it's, if you use a VS Code here, and you can directly import into your VS Code IDE. So this is one way to create your cloud native applications. Have all the, let me show you again, has all the APIs available to you. So it's in here, you can see the POM XML. Let me go to the Liberty one. Go to the VS Code, so it's show better. We go to Roadshow. We go to the Readiness code. You can see this is the Microprofile plugin. I mentioned earlier, you can create a Microprofile project, use the generate REST client interface template, and then the runtime here is you can Open Liberty tools and some other Quarkus tools and Payara tools, and etc. So it's one thing I show you here. So as you can see here is the Java version, compile version. Here is kind of all the Jakarta APIs available to you, and all the Microprofile APIs available to you. So this is kind of the Liberty plugin, the Liberty Maven plugin. So this is kind of the one. There's one file created. So it's a REST. This is the REST application. This so this is Java 17. Close that. So the other thing I want to show you is the other way is to do the start.microprofile.io. So there's some difference between the start.microprofile.io with the start.openliberty.io. So this is directly from the Microprofile community. So you can see demo. So here you can see the Microprofile versions. This is all the whole versions. The current version is 4.0. Why is it not 4.1? Because one is we want to make sure there's multiple implementations in the particular version. So at the moment, Open Liberty is one of the 4.1 the implementation. So we're waiting for another implementation. I think Quarkus is nearly there. I think Quarkus is already support 4.1. So we are going to add 4.1 on this list very soon. So this is 4.0. And then you can also you can choose a Maven or Gradle. And then the runtime, you can see 4.0 supporter Open Liberty, Wildfly, and Payara. You can choose Open Liberty. And Open Liberty, yeah, it's Java 8 or 11. So in this open source is slightly is not as more more recent than the Open Liberty starter, is because also we need to wait for others to come in. So the next job also we need to add the Java 17 as well. So you can see Java 11, and then you can demonstrate all the specifications. You can see, choose all, and then you download. So this is one way to create it. The other way to create cloud native application. So I can have my my VS Code ID, and as I mentioned earlier, already have the VS Microprofile VS Code extension pack installed. So it's as you can see, if I say okay, Microprofile generates a new microservice starter, the this is a group ID, artifact ID. Maybe I say road, like a show liberty, for example. And then the version 4.1 Open Liberty, I can say Java 11, Maven, I can say choose all of them, even including GraphQL. GraphQL is only one. This is only works for Open Liberty. I think if you choose Piaro or Wildfly, this option is not available because that runtime has not supported this one yet. So it's can see okay. I can see I will generate to my demo project. Can see add to the current workspace here. So here in this kind of I created two microservices and all able to demonstrate actually service A directly communicates with service B. This and the other thing is you can see the service or this kind of the service A, you can see the Microprofile 4.1 or the API is available to me, and also the Open Liberty plugin and etc. So if I want like start my service A and service B, I can just do a service A. I can do the Liberty Dev mode, Liberty Dev. So this will be like start my service A in the dev mode, and then will be download all the necessary like the JARs and install them. And similarly, I can go to service B, Maven Liberty Dev. By the way, this is not rehearsal, so it's hopefully it all goes well. So it's I'm a strong like believer for this Liberty, like all the developer joy experience. It's very easy to use. So it's you can see the kind of the service A. TCP general bound didn't, so that means I have other applications running on the service on this one. See. Need to stop this one. Now I go back. It's so easy, so it tell you straight away what happened. So this is the service B is up running. Go back to the service A is up running. So it's, you can see all the endpoints. So 9080, and also here it tell you which feature installed. There's no, for example, I'm not using VGB. You can't see any VGB being uploaded. So there's some other like the 9080 like Open API, 9080 health. This is for health check. This is Open API UI, and let's go there. Let's go to the.
While you're just navigating there, Emily, we've had a question in saying, is it planned to add plugins to the starter similar to Quarkus and Spring?
Sorry, can you repeat the question? I can't, I figured out my volume is quite down. So
It says,
repeat the.
Is it planned to add plugins to the starter similar to Quarkus and Spring?
Plug into the starter. What plugin are you thinking about?
I don't know if the person who asked that question would like to elaborate in the chat or come off mute.
Hi, Emily.
Hello.
Hi. Walid. So I'm talking about like if you go for Spring Initializer, you can add dependencies, which are libraries, to the project to be generated.
If you don't use this, you are thinking about a Spring plugin or?
No, was just comparing between the Microprofile Starter and the Spring Initializer.
Yeah.
So in the web page for Spring, you can add dependencies like, for example, Prometheus, Zipkin client, and GDBC like MongoDB. You can add them into UI before you generate the project. Yes, add dependencies. You see that?
Oh,
that
yes.
one?
Yeah, here, add dependencies. That's a great idea. I think it's other dependencies. This is the kind of this is the area actually so we try to focus on the microprofile starter. I think for Open Liberty starter, we want to keep it very simple. And even for generated code, we generate the minimum code. So it's just trying to lay out the foundation for you. For the microprofile starter, we have been trying to add a database support and etc. This is kind of the great idea. Maybe it's kind of the, we say, other dependencies. You can say it's which dependencies you want, right?
Yeah.
Yeah, this is a great idea. We will we will discuss it on the microprofile starter repo. I think it's this year we have been thinking to add the database for example, which is like a popular database and support it. I mean, some vendors is just want to support a different database and etc. And then we eventually didn't reach any consensus. Maybe if we provide this other dependencies at a job list or this link or something like that, that may be like a different runtime. Maybe you can pick different things. Or when you configure your application, you can configure different different dependencies and etc.
It might be quite useful for the Open Liberty starter as well, because then you can add in the features into the Open Liberty configuration. So the user can just say, I want MongoDB or this kind of database, and then it obviously provides you the dependency in your POM, but also could add that feature into Open Liberty, so the user doesn't have to worry about that. But yeah, just a thought, Emily.
Yeah,
Okay.
that's awesome, great idea. I think last time when I looked at Spring Initializer, I have not seen these dependencies. Is that a new thing, or I missed it? Do you know?
I've seen it like 1 year ago.
Or 1 year ago. So it's I didn't look at this initializer recently. Okay. Maybe always there, but I didn't look. Yeah. Okay. Thank you.
Thank you.
That's about sharing and the new innovation. Yeah. So here, one thing is kind of the go to endpoint hello world. So basically, I want to demonstrate here. If I demonstrate the dev mode. So it's if I do here, I will say the hello world. So the endpoint is. So hello world, I can say hello world. WUG Roadshow. It's not hard. Okay, so let's go back here. I just saved it. Oh, hold on. what's happening. So I will go to the load it. Any me restart. I think I might have other instance running. Me restart. Too many VS Code. The word. Git hello file not found. Any help? Debug session? It's never stopped working before. So Roadshow should work. File not found. This is should so that's the JSS. Let me create. Put it there. Let me see whether there's some other instances on my 2080 open UI. Oh, I know. So I have other instances running, which is why. Let me kill that, kill the other instance. Okay, we see. Okay, now. So let me clean it and try one more time. Do a nicotine. Okay. Okay. Move to so can injection working? So this is the health check. So you can see it's all working. You can see the matrix backend. And also this is Open API. And also this is the REST client directly talk to the service B. So if you do go to here, change the service B. Here you can see service B. Can save it, can see, and then go back here. You can see, so this is beauty or dev mode. So you can directly get a service B response straight away. So with that, I think it's pretty much towards the end of this session. So it's so recap. So it's this matrix. You can see all of the matrix like data, like for the duration and garbage collector status and fallback and injection. So this is more like hello world, and then the GWT. This is another. It directly is about security. So it's this is the client. This is the service A directly calling to the service A the secure. So it's it creates a GWT token and then call into the service B. So with that token, and then when the token created, you can see it's add the group and add the UPN. And then this is the backend is the security. So here, so you can see the token, you can see the like the claim value, and then here rules allowed protected. So because it's protected, allowed to access this backend, and also this client actually is the groups has protected. For example, if I change the backend saying, okay, only super can access me. If I save that, if I go back here, and look, it will be denied. The response will be denied. So just show you if I change it back to be protected, we will continue to get the response. see you
So
guys
we're
use
coming
on
close to time. I was just going to ask if there is any other questions for Emily, Grace, or Jamie. Please do leave them in the chat before we finish shortly.
Yeah, actually, I'm done. I think I demonstrated all of the microprofile, all these specifications.
Well, thank you very much, Emily, Grace, and Jamie, for everything today. If anyone has any further questions, please do let us know. Please do have a go at trying out some of those workshops that we've taken you through yourselves, and let us know any feedback or any questions. We'll leave this open just for a couple more minutes in case there's anyone else wants to ask anything.
Yeah, I can show you. I forgot to show one thing. So basically, I have done the welcome to WUG show. It does work. So previously, it didn't work because all the ports have been being hacked, being occupied by some other things. So it's yeah. So with that, you have seen all of these microprofile, the specifications, and then you can create your microservices using Microprofile and using Jakarta.
Excellent. Thank you very much, guys. I don't think we have any other questions appearing in the chat. So thanks everybody for your time today.
Yeah, great. Thanks for coming and stay with us for 2 hours. So this is
Thanks all.
yeah, dedicate your time. I hope you have learned something, and we'd love to hear from you and hear any feedback you have. Get in touch with us.
We do just have one question that's just appeared in the chat, Emily.
Yeah.
Don't know if you can see that.
Let me see. Chat. Any Saga pattern implementation example using Microprofile? Yeah, it's a great question. Yes, we do. Actually, if you look at the YouTube, if you search YouTube, Saga pattern, Emily, actually, I hosted a few, three, I think, kind of chat about Saga pattern, etc. For the Microprofile when we first were trying to experiment the Saga pattern. And the speaker was Reza Rackham. So it's kind of describe about the kind of some Saga pattern and other related technologies and etc. So in Microprofile, the long-running actions basically is about transactional microservices. So basically, it's in Microprofile, how can we do transactions? So we adopt this kind of Saga pattern. So it's basically microservice. They won't be long running. Basically, is the two-phase commit is no longer applicable for the microservice transaction. So because all these kind of things in microservice world is short-lived, so you can't hold the lock forever. So in this case, we use a compensation model. So basically, we just directly commit this transaction. And if something down the line, if something not working, we compensate. So this is the pattern we use in the Microprofile LRA. So basically, it's we have annotation at LRA and have other annotation at complete, at compensate. Basically, this is all this kind of stack pattern. So it's basically almost like you have the central management to oversee all the transactions, and then it will direct, okay, this is a transaction you need to compensate, and then that microservices say, okay, I will undo what I have been done previously. So this is kind of achieve eventual consistency. So this is kind of the Saga pattern, realization in micro profile community. Does that answer your question, Lisa? Lago. Okay, thank you. Let's take a right to the end of this workshop.
Excellent. Thank you very much, everybody, and thank you for your time today.
Yeah, thank you all. Thank you, Helena, for organizing this. And Diane as well for getting up so early.
Excellent. We'll end this session now then. Thanks, everybody. Goodbye.
Thank you. Bye.
Thanks, Helena. Bye, everybody.